Right now, tiny pockets of water are still surviving in direct sunlight inside Clavius Crater, exposed to radiation that should have destroyed them in hours. And NASA has no explanation for how they got there, or why they haven't vanished. Something is protecting that water, something nobody predicted. And what the follow-up data revealed is the part NASA didn't want made public this fast. Clavius Crater sits near the moon's south pole, a battered basin over 200 kilometers wide, visible even from your backyard telescope. In October 2020, NASA's SOFIA telescope, a modified Boeing 747 that flies above 99% of Earth's atmosphere, pointed its infrared eye at that crater. For decades, scientists assumed lunar water, if it existed at all, hid only in permanently shadowed craters near the poles, frozen in eternal darkness. Clavius broke that rule. This water sat in sunlight, direct, blistering, unfiltered sunlight. And that single detail turned a quiet research mission into a scramble nobody saw coming. Here's the part that should be impossible. The moon has no atmosphere, no magnetic shield. Solar wind slams its surface at nearly 1,000,000 miles per hour, and micrometeorites pepper it constantly. Under those conditions, exposed water molecules get stripped away almost instantly. That's basic physics, confirmed by decades of lunar samples. Yet SOFIA measured concentrations equivalent to a 12-ounce bottle of water trapped in every cubic meter of surface soil, not frozen ice sheets. Molecular water, chemically bonded, sitting in sunlit regolith that should have been sterilized eons ago. And when researchers modeled how long it should survive there, the numbers didn't add up, not by a little, by orders of magnitude. NASA's first instinct was denial through translation, insisting the signal was hydroxyl, a looser molecular cousin, not true H2O. That explanation held for about a year. Then the spectral data got reanalyzed, and the signature matched actual water almost perfectly. The next theory blamed impacts, micrometeorites supposedly delivering fresh water on contact, replenishing what solar wind burns off. But the math still doesn't close. The delivery rate is too slow, the destruction rate too fast. Caltech researchers admitted on record that no single mechanism explains the survival timeline. Something is replenishing or shielding this water faster than anything in the current model allows. And that's when the story stopped being about discovery and started being about damage control. Because here's what the follow-up survey found, the part that turned a strange anomaly into something closer to alarm. In 2022, a separate study using lunar reconnaissance orbiter data identified something researchers hadn't accounted for: micro-cold traps. Not the handful of giant, permanently shadowed craters like Shackleton everyone already knew about. Millions of them. Tiny shadowed pockets, some smaller than a coin, scattered across both poles, each one cold enough, at -163 degrees Celsius, to trap water ice indefinitely. Suddenly, the sunlit Clavius water wasn't an isolated fluke. It was a signal that the moon's water budget is vastly larger and far more distributed than any prior model predicted. Some estimates now suggest accessible ice equivalent to hundreds of thousands of metric tons, an amount that reframes the moon from a dead rock into something closer to a buried reservoir. And nobody can yet explain the full delivery mechanism. Ancient comet strikes, solar wind chemically forging water from hydrogen and lunar oxygen, deep volcanic outgassing from a moon presumed geologically dead for billions of years. Every explanation on the table requires the moon to have been more active, more chemically alive, more recently than anyone had built into the models scientists have trusted for 50 years. This isn't just an academic footnote. Artemis mission planners are already redrawing landing zones around these reservoirs, because water means rocket fuel, drinking water, and radiation shielding. The three things that make permanent lunar bases possible instead of theoretical. Which means whoever controls the richest cold traps controls the next phase of space exploration. And that race is already quietly underway between NASA, China's Chang program, and private companies watching every data release. But the deeper unease isn't political. It's that our basic model of how volatile compounds behave on airless worlds, the same model used to predict water and ice across Mars, Mercury, and countless moons, just failed its most basic test, on the one body we've studied longest. So if water can hide in plain sight in full sunlight on a world we thought we understood completely, what else has survived out there that our models say should be impossible? NASA hasn't answered that. Tell me what you think is really down in those craters.